You know, it's something we rarely think about, but every single time you stream a movie or train an AI model, or heck, even just send an email, you're using electricity, a lot of it. And as our digital lives just get bigger and bigger, so does their environmental footprint. But what if? What if our code itself could actually become aware of its own impact? What if it could learn to think green? Okay, let's really dive into this. Get this number in your head, 2%. That's the slice of the entire world's electricity that's gobbled up just by data centers. I mean, that's more than the energy budget of a whole lot of countries. This is the hidden cost of our 24/7 connected world, and honestly, it's a problem that's only getting bigger.
So that leads to a really fascinating question, right? For decades, we've been obsessed with optimizing our digital world for one thing: speed, performance. But what if we change the goal? What if for every single little computation, our systems could ask not just, hey, what's the fastest way to do this, but instead, what's the most sustainable way?
And that is exactly the question a new system called CEACO is designed to answer. Now, it stands for Carbon and Embodied Aware Compute Orchestrator, which is a mouthful, I know, but it's basically a framework designed to make that green thinking a reality. The best way to think about it is like a super intelligent Waze or Google Maps for your computing tasks. See, a normal GPS finds you the fastest route to avoid a traffic jam. CEACO does something really similar, but instead of avoiding traffic, it's dodging carbon emissions. It looks at all the possible places your data could be processed and picks the one with the lowest overall environmental hit. Okay, so here's a look at the entire system under the hood. I know it looks a little complex at first glance, but don't worry. We're going to break down the simple but really powerful idea that makes this whole thing tick. So how does it all get started? Well, it all begins with listening. Before CACO can make any kind of smart decision, it first needs to understand what's happening in the world around it, right now in real time. You can actually break this whole process down into 4 really simple stages that just build on each other. First, the system has to sense the environment. Then it has to calculate the carbon cost of all the options. Third, it decides on the absolute best path. And finally, it acts on that decision. So let's start at the beginning, with sense. This first step, it's all about gathering clues. Seriously, think of it like a detective. The system needs to collect all the relevant facts from the real world before it can even begin to solve the case of which computing path is the greenest. So to make that smart choice, the system is pulling in 3 key types of information. First, what does the user actually need to get done? Second, where is the cleanest energy on the power grid right now? Is it sunny in Arizona? Windy in Texas? And third, how efficient is the actual hardware available? It's all about getting that full picture. Okay, so the system has all its clues. Now we move to the absolute core of the platform, the AI-powered brain. This is where all that raw data gets crunched and turned into a really intelligent, eco-conscious decision. And this table just illustrates the fundamental shift in thinking perfectly. On the left, you've got the traditional method. Its goal is simple: find the fastest machine available, period. But the CEACO method, over on the right, completely flips the script. The goal now is the lowest total carbon impact. And to do that, it has to consider so much more. Where's the energy coming from? How efficient is the hardware? And even this thing called embodied carbon. So how does it calculate that total carbon? Well, it looks at 2 big things. First is operational carbon. That's pretty straightforward. It's the electricity used to actually run the job. But second, and this is so important, is embodied carbon. Think of it like this. There was a carbon cost to build the server in the first place, right? And to ship it to the data center. CEACO is smart enough to factor both of those in, giving you the true total environmental cost. So the AI brain just goes to work. It runs thousands of what-if scenarios in a fraction of a second. It simulates sending the job to all these different computers in different locations, calculates the total carbon cost for every single option, and then it picks the one single path with the absolute lowest environmental impact. So the brain has made its decision. The final stage is all about putting that green plan into action and, just as importantly, measuring the impact to prove that it actually works. The system then basically acts like a dispatcher, sending the computing job to the winning location. And that spot might actually surprise you. Sure, it could be a powerful, high-performance cloud server, if that server happens to be running on clean energy at that moment. Or it could be a small, efficient local device at the edge.
It could even be an older, slower machine if the job isn't urgent and can be time shifted to run overnight when the power grid is greenest. And you can't improve what you don't measure. So the final piece of this puzzle is a dashboard that makes the impact totally visible. It shows you, in real time, exactly how much carbon you're saving on every single task. It turns sustainability from just a vague idea into hard, cold data you can act on. And just look at what this means in practice. This chart shows the carbon cost for just one task. That big bar on the left? That's the standard way. Just run it on whatever cloud server is the default. But look at the incredible reduction when CEACO gets involved, either by running it on an efficient edge device or, even better, a cloud server that's powered by renewables. The savings are not just visible, they are significant. And this quote, this really gets to the heart of the entire idea. It represents a real shift in what we value in our digital world. We have the technology now to not just be fast, but to be smart, to be wise. We're moving from a world that only cares about speed to one that can actually optimize for sustainability. Which, of course, leaves us with a final thought to chew on. As AI, machine learning, and our reliance on data just continue to explode, that environmental cost is only going to grow with it. So, is building this kind of carbon awareness directly into the DNA of our digital infrastructure, is that the key to a sustainable future? Is this what responsible computing is going to look like?